Okay, so just going to explain a little bit about my framework here. This framework is something I built in GLBasic a long time ago. It's based on Corona SDK because I used that for a while, and then after they didn't really implement the features that I was asking them for, and so I decided I was just gonna go and build my own framework, which kind of works similarly because I was I was actually pretty satisfied with the way Corona worked, but they didn't have Z sorting and a whole bunch of other features which I would have liked to add manually. So when I built this framework, I had that in mind that I was going to kind of reproduce a lot of what Corona did, but at the same time, I'm also reproducing the uh, just my architecture, which I used in Corona as well. So in Corona, I built another framework, and I found that that was a really good way to build my games. So the combination of those two things are what I'm actually building in GLBasic here. So here I have the main, the main file, which is Phoenix, and it has some routines here that some I found on GLBasic forums, and some I just and a lot I tweaked all of them, but I just organized them in my own way. And this is my transition class. I use this to calculate easing and just allowing objects to move from one position to another and look really smooth while doing it. And then another is my display class, which uses layers and also object types. And if you see the jumps here, I have this is the rend. I render everything by going through all the layers and then drawing them, and then in that draw command, there'll be different ways to handle the sprites, map objects. Here is just a standard image that's not a sprite with animations or anything. This is text. I have the map files. So I have a way to handle everything, but it's all part of one unified system. And after I finished a lot of the groundwork, for example, this is audio. After I finished the groundwork, I put into Phoenix, I put in the device controller, and now it's just a simple another function, which is kind of just this loop, for example. Sorry, I'm getting a little confused here, but this loop is just the main loop, and this is actually how the whole game runs. It just keeps going through this over and over, and what this loop does is it just continually cycles through all the objects. For example, over here, it'll do some calculations for my frame rate, and then over here it'll update the math of my game. Whereas down here, when it starts at rendering, it'll update all the tweens and the transitions. It'll update the graphics here, and then it'll update the FPS and just update the window. And then where my actual game is actually here. And this is just one state machine. Everything is commented out, and really the only thing that this state machine really needs is this direct function, and all the director does is it just changes the name of the state. So when I say direct menu, it changes the state, which is a variable, to menu, and the game reacts based on that. So right here it says if state is equal to boot, then or else if state is equal to menu. So when I direct menu, basically it's going to continue the rest of the cycle, but then it's going to change it the next time it comes through this loop. It's the if here is going to be false, and the state machine is going to take me to the menu, and then it's going to have a different set of rules for that state of the game. So that's how I have this all set up right now. And for my display as well, I have this. For example, this is a display controller. It has a group of layers in it. So the display controller has general variables for everything, such as like RGB, the scaling, whether or not I'm playing full screen. It has variables to hold the FPS, a whole bunch of other stuff. It's really complicated. The more you build on this, the more you kind of just add to it, and then you can't really explain it all in one go. You have to kind of tweak it. Then in this display layer is pretty simple. It just has the tint that you're gonna draw them at, and then it just holds a collection of objects. and then a variable that asks if I want to resort those objects because the Z position, which is the Z sorting, which is a feature I really needed in Corona, but they never put in, is something I really needed. So if it's true, if the resort is true, then it's going to actually resort all my objects. And it doesn't do it every frame, it just does it whenever I make a change to the Z dimension. And all of my functions know when this happens, and it'll just queue that layer to be set to true, so that it's going to change it. And then it'll automatically switch itself off, so that I'm not wasting processing on it. So the actual display objects are kind of complicated. They know their upper left, bottom right, and corners. They know whether they're mirrored, like horizontally, vertically, or both. They've got their own scales. They know their original height and width. And if it's a map tile, then it has a completely different set of variables, which can be ignored if it's a different type of object. And then if it's fonts, it uses these, and basically all objects are every object in this game can be a different type of object, but they're all part of the same type, which is display object. And in the sub of those display objects, there's also other types, which are like sprites and stuff, and it's all here. So, for example, direct menu, and then I just load the fonts first. So if I were to run this, it wouldn't actually do anything, because everything's commented out right now. So let's just run it. You see, nothing happens, and it's running at 60 frames per second. But if I were to put in a character, let's say first this line here, what it does is I ask the display to add a scaled sprite. So what I'm doing is I'm loading the sprite called tpfinrunning.png. It's a PNG file. I don't put the extension on because I only use PNG files. And then it asks if it should be smooth or use nearest neighbor filtering. And then it also asks if it's animated. In this case, it is animated, so it's going to say true. So it knows that to load the sprite in, and the sprites are texture packer sprites. So it automatically goes through the whole atlas and loads that for me. And it just creates a sprite, but it's not actually creating the object that's going to be displayed. And over here, what I do is I add an animation to that sprite. So from frame 0 to 7 of those frames, it knows that it has a running animation called running. Now, when I actually create the sprite, I say display.display group 3. So I'm in the third layer of the display group, and I could change this to any layer, but I actually have a system here where I put the displays. The layer 0 is a skybox, layer 1 is a background, layer 2 is another background, layer 3 is the playground, and this is mainly the playground that I like to activate physics in for box 2D. And then here's the foreground, which are objects in front of that layer. And then there's the effects, overlay, UI, and menu, and some of them are excessive. I don't really need all of them. But also noted that in these layers themselves, they also have Z sorting. So I don't have to worry about using all of them. I could just use one layer and still have Z sorting. But it's really nice to keep them separate because it's just an organized way to keep. It's just an organized way to keep your work. And over here, what I can do is so what I've done is I've loaded the sprite. I've defined the running animation, which is frame 0 to 7 in the sprite. Over here, after I've defined that sprite, what I've done is I create a new sprite object called Fin, and I've given him this sprite, which I defined before. I've given it to him here. So because I've defined it, I can add it here now, and I've told this object that this is the name of his sprite. So this is pretty much more of an avatar rather than a sprite, and I'm giving it to this actual sprite that I'm creating. And below here, I'm setting its animation as running, which I defined here. And over here, I can just, this is not really useful. It's just, I'm setting the mirror position of him, and in this case, it's mirror horizontally. So he's actually going to be mirror horizontally is actually mode 4, which is he's just going to be flipped horizontally. It's not necessary, but I do it anyways. And then, so if I were to run this right now, it would load my character, and he would be running, because the engine takes care of it, and it scales him exactly as he should be. to the screen as well. Yes, I should show the scaling as well. So over here, under scaling, I can set the default resolution which I use, which is in this case 900 by 600. And then over here is where I set whether it's full screen or not. And if it's full screen, it'll actually it depends on this this next parameter, which is a string. And there's different types. For example, normal will just scale it while preserving the aspect ratio. Stretch will scale it while filling the screen exactly. And then none will just keep it 1:1. So even if I set this to full screen, and I set the resolution to 1920 by 1200, if I set it to none, 1:1 pixels, it will actually make it 1:1 pixels. But it might be a little weird because you'll have to think about like it's good to have scaling because resolution is always different. And if you set it to 1:1, then if anyone doesn't have a 1920 by 1200 resolution and you're working at that resolution, then your game's gonna look weird on their screen. So it's always good to work on one resolution and enable scaling for this framework. I've set an easy transition class. So what I'm doing is this is my function called transition dot towards, and there's all different types of sub functions for transition class. But what it does is I'm asking Fin, the object Fin, which I created here, to move in using this type of easing to this position, and there are a whole bunch of other functions which I've quoted here. So now when I run this, my character is going to run from right to left. And he's going to the exact position I set him to. If I were to turn on the scale, if I was to set to full screen, for example, let's see this. You'll see that it's actually scaled, but it's still 960 by 600, but it's scaled to fit the screen, and it's actually it's not running at 960 by 600 full screen. It's running at full screen of my native resolution, but it's scaling the 960 by 600 to that native resolution. I can also just load images. For example, this is just a banner. So I'm adding a scaled image, which is a title image. So this is just a standard image that I use for my titles. And over here is where I create the actual sprite and give it the avatar of that image. And over here, I scale it. But I didn't actually scale it to anything. I scaled it 1:1. It's kind of a useless line here. But, you know, if I wanted to scale it, I could. And I didn't have to put in that line in. I could have kept it quoted. So it's scaling. You can't see it right now because it's on a black background, but it's actually got some transparencies in there. I can also add... Actually, let me just put on the background. So you can see what I'm talking about. So you can see that it's got some transparencies here. This is the title image for it. This same sprite running. I can add some text to that banner. What I'm doing here is I'm just creating the banner text. It's just text, and then this is where I'm setting the scale, and I'm actually setting it to half because my text fonts are actually really big. And I don't really have a lot of faith in the font section of my framework yet. But so far, I've got everything to scale pretty good. And also I can transition using transition.towards. There's also transition from if you want to bring it from a position to another position. And it also allows you transition with alpha. So I'm running it now, and you see it should scale up and fade out. Like, the background is a tile map. It's actually a huge tile map. It's like I think it's huge. But it's actually larger than this. It's actually probably double the area that it actually moves in this transition. But I worked really hard in getting this to work. Still not perfect because of scaling up and down at different resolutions, and also sometimes if it's lagging, it doesn't step properly. And then I also have a simple audio. I just load anything here, and there's functions to play, pause, so I can add a sound to this. So there's I can play a BGM, and right now I only run one BGM at a time, and I can always change that BGM to something else, which is just background music. Then I can also run simultaneously to the BGM. I can run several sound effects. In addition to that, I can tint the screen. Let's say I can either use a value which I've defined in the display for the function for this, or I can just use custom and then set other variables for the RGB values. So if I want to make it red, I'll just set it to red. I'll test it and I'll run it, and everything will look red. And that's pretty much what I've got so far. To go more in depth with this, you have to kind of look at it in a nested. You have to go look at this in a nested way. For example, I have the main type, which handles everything in terms of the display and graphics, is called. Okay, so I set global display as display controller, and that's basically making this this one variable which holds everything. And this is the type, the display controller type. So this display is of this type, and within this one display, I have a group of displays. I have a display group, which are all these different display layers. I have a bunch of sprites, which are whenever I load a new sprite or avatar in this case, it loads the index in this sprite so I can reference it. And then same with images and fonts. I keep images and sprites separately. And so if I go, so in my display, I have display layers right here, as you can see under the type here. So if I were to go down to the display layer, it's another story. So over here I have a display layer. This is the display layer type, and below that I have a group of display objects. So below that, if you keep going, right here, then each display object is a unique object of its own type. I give it types to separate them, and then depending on the type, there's a different way to render them. So let's say I was just loading a sprite. So I set the alpha mode, I set the transparency to 000, which is black. The mirror mode is equal to the mirror mode passed to the object from its own variables. All the functions that modify, for example, my transition class, it knows to act on a certain object, so it modifies the values of that of its own transition first, and its own transition, when it's cycling through, it will modify an individual object in the display objects. And basically when it's drawing, what it will do is just set variables from the object itself, and it's not going to do, I set it so it doesn't do any calculations anymore. It used to do calculations in the draw function, but I think that was slower because the draw function happens all the time. So in this case, it's purely just drawing it now, whereas before I used to actually have a lot of calculations in here, and now I prefer to have none. I used to, even like just if you're just adding the scale or multiplying, it's a lot of work. So I actually do that now, and I believe if you go to my display controller.update, over here it actually goes through display group, and it goes through each display group. Say it goes for loop goes through each display group, and it asks each one to recalculate itself. So the recalculate functions are here in the layer. So each layer is going to recalculate, and depending on whether it needs to be updated even. So there is a I believe there is a variable which knows whether or not it needs to be updated, and then it'll just go through, and depending on its type, it will update it. And then that's where it happens, and that actually only happens once you make a change to the object. So with the exception of transition, which self-manages and makes modifications and tells it to recalculate, it's pretty efficient. And also the way that things work, for example, any object that goes out of bounds is actually set not to draw, as well as the tiles, which was pretty complicated to set up. When it draws tiles, it doesn't draw anything outside of the screen, so that really helps a lot with the performance. So nothing here that's completely off screen, like out of its bounds of drawing, is actually being displayed. If I were to go to for example, if I set to full screen and I set scaling to none, it's gonna go 1 to 1, and I think this should show how the mapping is kind of just stepping. No, it's still alright. It doesn't do that because it doesn't show because in my draw function I set it up so that or in my I believe it's a render function. It sets there's a line in there that sets it so that this set screen here. So it actually sets the screen to cut off anything off, so you can't see it anyways. So that's actually a pretty useful function. If I were to, if I were to turn it off, you would see it, but I don't want to mess with this right now. So yeah, that's pretty much it. It's really useful to deal with objects in this way because you don't want to keep calculating its scale all the time, and you don't actually. I don't even have to think about that anymore. As you can see, I just set one set of values, and it just has universals. It just does the scaling by itself. It's a lot easier in other engines, but in this case, this is how we do it. So when I add a new image, I give it the file name, I give it the initial width and height, and whether or not it's smooth. And what happens is it'll just create a temporary file which it's gonna push into the group of objects. And then from there it's gonna go to new image, and then new image is gonna do all the calculations based with the scaling right here. As you can see, x times display.scale minus the center, because I calculate everything from the center, because I think that calculating from the center is the best way to scale everything. It's the only way to make sure that all your stuff stays centered and to have an anchor which is universal. If you work from the bottom left or something, you never know how where the image is going to be. Well, as long as you choose one place to work from, I think it's okay. I chose the center because it just seems to make sense, because if I'm going to go minus 40 and I know I'm off the screen, then plus 40 is going to be off the screen in the other direction. So it's just easier to think about. Then that should be pretty much it. I mean, there's more to it, but and obviously if you're looking all through this and you're just starting out, it's a lot of work. But you have to do a lot of the groundwork before you can actually see the results. And that's a lot of groundwork, and I actually had to build this twice. I did an engine for Gundam, and it was not very it didn't work very well. So it was like this one, and I had a few more features, but some of the ways it was built wasn't built right. Anyways, I'm not gonna talk anymore.